The focus of this lesson is on solving exponential equations in which each side of the equation can be written in terms of the same base. So the procedure for doing that is to determine what that base would be. So sometimes you use prime factorization to help you determine what that same base is. And then once you get it in terms of the same base, you're going to set the exponents equal, solve, and then check your solution. So let's go ahead and take a look at an example. So we have 2/3 x equals 9/4 to the third. So if we look here, 2 over 3, 2 is prime and 3 is prime, so you can't really pull that down any further than what it already is. So I would keep that as is. So this is still 2 over 3 to the x power. But on the right hand side, 9 can be written as 3 to the second, and 4 could also be written as 2 to the second. And then that was all raised to the third power. So you get 2/3 to the x equals, if you think about this, this would be 3/2, the whole thing, raised to the second power, and then that is raised to the third power, since both the numerator and the denominator were raised to the second power. So this is 2/3 to the x equals 3/2 to the 6. If you take a power and raise it to a power, you multiply the powers together. But then those are not the same base quite yet because they're reciprocals of each other. So to account for that, on the right hand side, if we raise that to a power of a -1, then we can take the reciprocal. So then that would become 2/3 to the -1 times your power of 6. So I'm just trying to show every step. Some of this I would take some shortcuts on, but the sake of the math, that 2/3 to the -1 is equivalent to your 3/2 that you had originally. So this becomes 2/3 -1 times 6 is raised to the -6. And now you have like bases on the left hand side and right hand side, so set your exponents equal, and you see that x would be -6. Let's go ahead and take a look at another example. So on the left hand side we have a base of 3, and then that's raised to the x power. On the right hand side we have 9 raised to the x minus 1 times 27 raised to the 1 minus 3x. Well, 9 can be written as 3 to the second, and then that whole base is raised to the x minus 1. And 27 can be written as 3 times 3 times 3, which is 3 to the third. And then that is raised to the 1 minus 3x. And then to keep going, we have 3 to the x equals, raise a power to a power by multiplying. So this is 3 to the 2x minus 2, because you have to distribute that 2 onto the x minus 1. And then times 3 to the third minus 9x, because you have to distribute that 3 onto the 1 minus 3x. Then when you take the rule that you multiply like bases, you keep the base and you add the exponent. So I need to take that 2x minus 2 and add that to 3 minus 9x, since those are the exponents. So the like terms we need to combine together in those powers, so we get 3 to the -7x plus 1. Now I have like bases on the left and the right hand side of this equation, so I can go ahead and set the exponents equal to each other and solve for x. If I add 7x to both sides, I get 8x equals 1. Divide by 8, I get x equals 1/8. And then you would check it, and you would see that it works out. And so that completes this example. And we'll go ahead and take a look at one more example where we can write in terms of the same base on both sides of the equation. So we have 2 raised to the x to the second power equals 8 to the 2x, which can be written as 2 to the third, because 2 to the third is 8, raised to the 2x power, times 1 over 256, and then 256, if we think about it, is 2 to the 8th power. So 2 times 2, 8 times, would give us 256. So this is 2 to the x squared equals 2 to the raise a power to a power you multiply, so you get 6x, times 2 to the negative 8. And the reason it becomes negative 8 is you do the reciprocal of 1/2, which is just 2. So 2 raised to the negative 8 power. Then we are multiplying like bases together, so we can add the exponents together. So we keep the base and we add the exponents, so it's 6x plus a negative 8, so 6x minus 8. So now we have like bases, we can go ahead and set the exponents equal. So we have x squared equals 6x minus 8. You're now solving an equation with a quadratic, so you should move everything to one side of the equation. So that one side is 0. If you can factor, factor. If you can't, use the quadratic formula. In this case, we can factor. Negative 4 and negative 2 multiply together to give us 8 and add to negative 6. And so if we set each of those factors equal to 0, we can see that we get x equals 4 and x equals 2. And so our solution set is 4 and 2, and then you would check each one, and that completes solving exponential equations as both of these work out.